Let us discuss set operations in SQL. Set operations in SQL. The important set operations in SQL are union, union all, join, intersect, as well as minus. Union, union all, join, intersect, and minus. Now let us go through what is this union. We know that set operation union, there will be two sets. Union of those two sets we studied in a relational algebra also, the same thing. It will combine two sets. Union will combine two sets. And the result will be combination of those two sets. But here in SQL, the result will be combination of two or more select queries. Select query will select data from multiple tables or from single table, multiple columns or single column. So a result can be obtained. A table kind of thing can be obtained as a result from select query. From multiple tables or a single table, multiple columns or a single column. Okay, however you want, you can get some values. We call that one as, we consider that one as a set and perform union operation. Perform union operation by using those two results. That is what is union operator. If you look at the syntax, first we write the select query. First select query. So select some column names from some table name. Another select query. There are two select queries, 1 and 2. In the middle of those two, we are performing the operation. Okay. So of course here it will remove the duplicate values or duplicate rows, and make sure that there should be same number of columnar fields along with the same data types. Data type and number of columns should be same in the select statement. Each select statement result. That is nothing but first select query will return a table kind of data. Another select query will return another table kind of data. The result should match in terms of number of columns as well as data type of each columns. When you look at one small example, for suppose we have one table with name employees. ID, first name, last name, and salary are the attributes or columns. Another table, customers. Okay, same thing, ID, first name, last name, but in the place of earlier it was salary, and now it is city. Okay. Now what we are doing over here? We are adding two select queries. Select first name and last name, that's it. We are not taking ID, we are not taking salary, we are getting only first name and last name from employees, first name and last name from customers. Okay, so what happens is some of the employees may become customers also. Okay, that's nothing but an employee is working in one company and the same employee is purchasing something from the same company. So their name will be in employee table as well as customer table. Okay, so we are performing union operation. Okay, after union, when you look at the output, Ethan, this is from the first table. Tony from the first table. Sarah from the first table. Rick from the first table. Martin from the first table. And Maria from the second table, Fran from the second table, Dominic from the second table, Thomas from the second table. Both are, joined, otherwise combined. Both the results are combined. That is what union, apart from the nothing is there. But when you observe carefully, we have seen Martin blank in employees table as well as customers table. But there is only one employee blank, one entry or one row, Martin blank in the final result of union operations. Means what? Duplicates are removed. Okay. So 5 plus 5, 10 rows. Here 1, 2, 3, 4, 5, 6, 7, 8, 9 rows are there because one is repeated. Okay. So that is about union operator. Not only union operator, you can make use of union all also. Union all. Same query. What it will do. So includes the duplicates also. Which one? This union all will include the duplicates. Union, no duplicates. Union all with duplicates. Then the next operator is SQL Join. What it is? This also combines two tables. That's what join. Okay. So join class is a way to retrieve information from two or more tables. But this join is different. Union is different. Join is different. In the union, after the first table data, second table data is combined downwards. But in join, the point here is we are keeping two tables side by side. Union at the bottom. This is the first table, the bottom one. Okay. In join, it will be like this. Okay, this is one table, this is another table. For suppose two tables, those two will be joined like this. Okay. When you are joining, okay, of course, different criteria will be there for joining purpose. Those are different types of joins. Normal join is also called as inner join. Outer join and cross join are different types of joins. In outer join, again, we have left outer join, right outer join, and full outer join. Okay, those are different types of joins. All those same concept, but small variations will be there. We will look into all those things. Moving to the next slide, that is nothing but the first one, inner join, otherwise the normal join. When you are joining, we have to perform Cartesian product. Cartesian product in the sense, for suppose these are the rows in one table, and these are the rows in another table. For suppose the first row will be joined with all the rows in the second table. Similarly, the second one will be joined with all the rows in the second table. Similarly, the third one will be joined with all the rows in the second table. Okay. Likewise, Cartesian product. For suppose we have A and B. Here, for suppose C and D. These are two different tables. This is table 1, and this is table 2. Now, Cartesian product T1 into T2. T1 into T2 will give the output like this. It will be like this. A joined with the C, A joined with the D. Then B joined with the C, B joined with the D. That is what Cartesian product. But in join, what will happen is, okay, sometimes there will be some other columns also. Suppose x1 and x2. Some more columns in table 1. There are also x2 and x3. Okay. So based upon this x column, Okay, these two tables T1 and T2 can be joined. Where? How? Because if suppose T1 X is equals to T2 X. If the value in T1 table X value is equals to the value in T2 table X, then you join those two. According to that, when you go for join of T1 and T2, the result will be like this: join of T1 and T2. Okay, this is first of all join. Okay, the result will be like this: B X2, B X2, and C X2. Okay, instead of writing 2 times X2, only once you can write. So B C X2 will be the result. Okay, that's what. So in join, we will perform Cartesian product, but along with that Cartesian product, there will be a condition. What is the condition? Sometimes some data will be there in both set A and set B. Based upon that common data, we will join set A data with set B. That is what join. That is what join. So if you look at some examples, then we can understand all those things. So let us go through this example. Inner join or join, what it will do? It will return some rows. What are those rows? Where there is a match values at both joined tables. Match values. See here, B is joined with the C because there is matching in the case of attribute X in T1 as well as T2. Okay. So that's what, for suppose employees and a department. If you join, for each and every employee, there will be a department number in which he is working, he or she working. Okay, in department table also there will be number for each department. So along with employee details, department details can be combined, can be joined together, where the department of the employee is equals to the department number within the department table. Okay, that condition is important. So that is what we do in join. Okay, it is not simply a Cartesian product. Cartesian product with a condition like that. Okay, so there should be some matched values or some columns, similar columns in between those two tables. Based upon those values, similar column values, we will join those two tables. Okay, similarly we have outer join. So in outer join, there will not be any related rows. Okay, an outer join will return the rows even after they don't have related rows in their join. Simply we will join. Okay, of course here we have left outer join, full outer join, as well as right outer join. Okay, so left outer join means here we use two tables, and in those two tables, one table is in the left side, for suppose, and the left outer join. After combining with the after joining those two tables, sometimes on the left hand side table some values will be left over. Those leftover values will be given as output, even though there was no matching. Similarly, full outer join on the left hand side as well as on the right hand side, both tables extra data will also be kept in the result. Right outer join, only the right hand side tables related extra rows will be displayed in output. What is this? We can understand this concept through examples properly. For suppose even you can understand by using these diagrams also. So one circle is one table and another circle is another table. We are joining these two. We are joining these two, and we are keeping the entire left table, left side specified table entirely. Right hand specified table entirely. Full means full join means both the tables entire data will be placed in the result. Okay, we can understand this concept through examples, and those examples will be followed after this slide. And the last join is cross join. Cross join is completely Cartesian product. That's nothing but we take one row of one table, join with all the rows in the other table. Second row in one table and join with all the rows in the other table. Like that, so on. Each row in first table will be joined with all the rows in the second table. That is what Cartesian product, or it is also called as cross product. Let us go through examples. This is from Wikipedia, one example. Of course, the SQL queries are little bit, those syntax are little bit different, but concept is same. Okay. So to get the concept, I'm using these tables. First, suppose there are two tables, TBL suit and a TBL light. Suppose two tables. Okay, the data is like this. Okay. Concentrate on the colors. Concentrate on the colors. Now the first one is we are going for join. Okay. So let us. Okay, let us go through this left join. Left join first. Left join. Left join means here there are two tables. Table suit is joined with table light. Okay, this is table suit and this is table light. Okay, so left join means all the rows in the left table is placed, and on the right table we are placing only the matched. We are just matching and combining. Okay, so the condition is based upon the color. Okay, the color in suit should be equals to color in the light, then you join. So the color is red. Okay, so here also the color is red. So the third row combined with first row, and the fourth row combined with the first row. Okay, because of that we got here two. Okay, so this is third row in the first table, fourth row in the first table combined with first row in the second. That's it. So this green is not matched. That's why it is not displayed, and it is left out. And that is why the left out things in the left side. Left out things in the left side. That's nothing but black is also placed inside the output. Then the other one is right join. In the right join, right side table every data will be placed. We are matching, otherwise we are joining based upon the color match. Okay. Now the color is the color matching is red. So red is placed because it is matched. But on the right hand side, green is also placed. That's nothing but on the right hand table, the leftover data is placed here. And the left hand side rows will be null. These two are null values. Okay. So that is what left join as well as right join. And of course, this is a Cartesian product. In fact, in the join, they have done Cartesian product. Okay. So I think here I need to rethink. So I'm not telling this point. So left join, right join. Let us go to one more example so that we can understand properly. Now, so in this example, suppose we have set A as well as set B. Otherwise, table A. Okay, set A, set B. Or two tables. Okay, AA and BB are columns. In AA, 1, 2, 3, 4. In BB, 3, 4, 5, 6. Okay, first select star from A, left join with B on the condition AA is equals to B. What are AA? Column names. What is A? For suppose a table. What is B? It is another table. We are going for left join. Okay, so this AA is going, this is one table. Consider this one as one table. And this is another table. Okay. Now we are joining those two. Now when you are joining, it is left join. So left hand side, every data will be placed. Okay, item 1, 2, 3, 4. On right hand side, only 3, 4. Why? Because okay, item 3 in A is equals to item 3 in B. Item 4 in A is equals to item 4 in B. So joined. But item 1, no element. So because it is left join, all the items in the left table are placed as they are, but on the right table, null values. What happened to 5 and 6? They are not considered in the output, the result. In the case of right join, okay, same, but A is equals to BB, the columns, and in the place of left, we are going for right join. On the right hand side, all the columns, all the rows are selected. Okay, right hand table 3, 4, 5, 6. Okay, and the left hand side only 3 and 4 because only 3 and 4 are matching with BB. Okay, that is what right join. And then inner join. Inner join means exact leftover things will not be considered. Leftover things will not be considered. So 3 is equals to 3 of A is equals to 3 of B. So join. 4 of A is equals to 4 of B. So join. So remaining things are no matching. That's why they are not at all joined. That is what inner join. This is what the actual join. Okay, now full join. Full join means on the both sides, left side table and right hand side table, if there is no matching, then empty null value will be placed in the result result data. Okay, so item 1, 4 no matchings. Okay, 1, 2 no matchings. So they are kept as they are in B null. Item 3 matching, item 4 matching. But in the second table, item 5 and 6 are no matchings. That's why in left hand side table, null values are placed. That's nothing but full join. Both in the left hand side table, leftover rows and right hand side leftover rows, both will be included in the output. Finally, cross join. There is nothing but Cartesian product. What will happen? 1 is combined with 3, 1 is combined with 4, 1 combined with 5, 1 combined with 6. Means what? The first item in first table is combined with all the items in the second table. Okay. Similarly, the second item in the first table is combined with all the items on the second table. So that is what cross join. That is what cross join. Okay. So that is about joins. So we have seen union, we have seen union all, then join. In join we have inner join or normal join, then outer join. In outer join we have left outer join, right outer join, full outer join, and cross join. Okay, those are all different joins available in SQL. Those are all operators. Okay, those will be used in the middle of select queries. And intersect operator. Intersect. Again, what we discussed in relational algebra is the same thing. Okay, here two sets will be there. The common data in the two sets will be the result. Apart from that, nothing is there. There will be two select queries as we have seen in union as well as join. Two select queries. This is one select query. This is another select query. In the middle, we are going for intersect. Okay. So it will at the end, see, first select query will give one result, second select query will give another result. Those two results it will take, and whichever rows are there in both results, those only it will consider. That's what this point here. Rows that appear in both the resulting sets will be the output for the intersect, and it will remove the duplicates. Okay. So one example. So we want orders from in between 1 and 100, and we want orders from in between 50 and 200. So the commonality is 50 to 100. So the orders in between 50 to 100 will be the result for this intersect query. So example. For suppose there are two tables, table A and table B. This is from this particular website. Okay, .NET tutorials. Okay. Now, table A, Pranaya, Priyanka, Preeti. Table B, again Priyanka. Same data, Priyanka, female IT. Priyanka, female IT. These are the same common data. Okay. So we are selecting everything. Select ID, name, gender, and department from table A. Again, select name, ID, name, gender, department from table B. Both entire data is selected, but the common rows only will be selected for intersect. The middle one is intersect. Okay, so sorry, Preeti is also is common. Okay, Preeti female HR. So those two rows are displayed as output as a result over here. Okay. But here intersect is similar to inner join. Intersect is similar to inner join, but duplicates are in. Okay, so we have seen union, union all, join, intersect, and finally minus operator. We have two sets. For suppose R and S, R minus S if you write. Okay, so we have R set and we have S set. If you write R minus S, the result will be R, and from R, S will be removed. Means from the set, there will be some rows. In those rows, if anything is present in S, those rows will not be considered in the result. If anything is present in S, those rows will not be considered in the result. For suppose table 1 we have 1, 2, 4. Table 2 we have 1, 2, 4, 5. So if I write table 1 minus table 2, select star from table 1 minus select star from table 2. If you write like this, what will happen? So from 1 to 4, 1 to 4, 5 will be eliminated. Means what? 1 to 4, all the 1 to 4 which is in table 1 is also present in table 2. So the result will be nothing. For suppose if you write S minus R, the result of R minus 1 S and S minus R totally different. So those two are not equal, right? So if I go for table 2 minus table 1, table 2 is 1, 2, 4, 5. Minus table 1 is 1, 2, 4. In 1, 2, 4, 5, if you remove 1, 2, 4, the result will be 5. So the result is 5. Okay. So that is what minus operator in SQL.